Welcome to the Extreme Broadband Engineering MoCA 101 Overview Training. In this video, we'll look at what is MoCA, what can MoCA do, how does MoCA work, and we'll look at the MoCA signals. MoCA, Multimedia over Coax Alliance. MoCA is an association of equipment manufacturers, service providers, consumer electronic retailers, semiconductor vendors, and test and measurement equipment companies developing and promoting a new standard for home entertainment networks. MoCA is a medium to distribute and share information among devices utilizing the existing coaxial wiring in a home, MDU, or building. MoCA is home networking. MoCA can network a home by carrying large amounts of information and data through existing coaxial wiring. There are currently 3 versions of the MoCA standard. MoCA 1.0, which accounts for about 90% of the MoCA installations, can deliver 135 megabits per second throughput. MoCA 1.1 can deliver 175 megabits per second. And MoCA 2.0 can deliver between 400 to 800 megabits per second, depending on which options are used, such as channel bonding. MoCA can deliver multiple streams of HD content and data services. One of the biggest drivers for MoCA in CATV networks is multi-room DVRs, which enable video recordings on DVR to be shared with other set-tops. But MoCA is capable of so much more, such as multi-room gaming, data networking, and creating other home networking solutions, as well as being able to support future applications. When putting the MoCA standard together, there were certain installation objectives. It had to be easy to install, either by the cable technician or the homeowner. It also needed to seamlessly support any type of cable configuration, such as home run. Which is the preferred wiring configuration of most cable operators, where all cables originate at one central point, normally the demarcation point, and each outlet has a dedicated coaxial cable. The other cable configuration type is called loop. This is where the signal from one splitting device will feed another splitter on some or all the outlets. This is found in some multiple dwelling units or homes that are wired by the homeowners. The MoCA signal is very robust and can work in both of these cable configurations. And there should be minimal need to replace splitters and coaxial cables. And lastly, any MoCA device called a node will be able to communicate with any other MoCA-enabled device. The MoCA physical topology looks the same as a traditional cable topology. In this example, a two-way splitter with each output port feeding another two-way splitter. When we look at the logical topology, this is where the big difference is between a MoCA network and a traditional cable network. With the MoCA network, any MoCA-enabled device can communicate with any other MoCA-enabled device. Where in a traditional cable network, the communication path is from the head end to each device and from each device back to the head end. With MoCA 1.0, it supports up to 8 nodes, and MoCA 1.1 will support up to 16 nodes. So if we look back at the physical topology, the MoCA signal will flow and communicate between any MoCA-enabled devices and can take many different paths. Each MoCA signal path normally will travel through one port-to-port isolation path, and this will normally be the location of the most attenuation to the MoCA signal. For more information on MoCA signals through passive devices, see our video on MoCA and passive characteristics. By utilizing the higher frequencies, typically 1125 MHz to 1525 MHz for cable TV applications, MoCA-enabled devices can communicate by transmitting and receiving unique data through the home's existing coaxial cable and passive devices. Let's look at the MoCA frequency spectrum. Traditional spectrum used for cable TV starts with the return at 5 MHz to 42 MHz. At 50 MHz starts the traditional analog signal, which normally extends to 550 MHz. And depending on your system, the digital signals go from 550 MHz to either 750 MHz, 860 MHz, and a few up to 1000 MHz. The MoCA 1.0 and 1.1 signals fall between 860 MHz to 1600 MHz. As this is an area that is not typically used by cable TV, there won't be any interference issues. With MoCA 2.0, they extended the bandwidth to 1675 MHz and then added a block of bandwidth down in the 500 MHz range for the satellite operators to use. In the MoCA bandwidth, MoCA 1.0 and 1.1 uses 50 MHz wide channels and are broken into 4 channel bands, band A, B, C, and D. Band D, which contains 8 channels, is normally used for cable TV MoCA services. Only one channel can be used at a time in each channel band. MoCA uses orthogonal frequency division multiplexing, which is a frequency division multiplexing scheme utilizing a multi-carrier modulation method. 224 closely spaced independent subcarriers are used to carry the data. The data is divided into several parallel data streams of channels, one for each subcarrier. The modulation technique of each subcarrier changes based on the physical characteristics of the signal path and will optimize the modulation accordingly. Each subcarrier communicates using the best modulation possible from BPSK to 256 QAM. The advantage of orthogonal frequency division multiplexing is its ability to cope with severe channel conditions such as high attenuation and reflections. This is done by probing the signal path for impairments. If you wanted to watch something in the bedroom that was recorded on the multi-room DVR in the living room, the MoCA device will probe the signal path for microreflections and high attenuation. The data rates between MoCA nodes will vary depending on the physical characteristics of the path between the transmit and receive nodes. MoCA 1.0 and 1.1 maximum physical layer data rate is 270 megabits per second. Due to forward error correction and additional overhead, it reduces the actual data rate, and MoCA 1.0 throughput is 135 megabits per second, MoCA 1.1 175 megabits per second, and MoCA 2.0 throughput is 400 to 800 megabits per second. Throughput is reduced based on the number of connected devices. One MoCA device assumes the role of network controller. Usually this is the first device on. The network controller sends out beacons announcing the network and authorizes the MoCA node access to the network. MoCA uses time division multiple access, and the network controller schedules network transmissions and broadcasts medium access plans. A MoCA home network has a large capacity and is very flexible, enabling you to watch a recording on the living room TV or to pause that program and continue to watch in another location. or watch an additional recorded program in a second location. Or share data files between computers. Or access photos from a media server. MoCA is a network customized to a single home. Let's review what we've covered in this MoCA 101 overview. We explained what is MoCA, looked at what MoCA can do, showed how MoCA works, and explained the MoCA signal. Thank you for viewing this video on MoCA 101 overview. For additional training topics, see our website at www.extreme-broadband.com.